It's funny, I took a class here with like a Native American class, and the guy let us use all our notes, and the person next to me always got like D's, and he's looking at how do you always get A's?
I'm not retarded.
He lets us use our notes. Yeah.
Can we move over to number 13?
All right, so I got a question about number
8.
8, and then we'll do number 13. So problems like number 8.
A quick review.
Oh,
Kind of forgot about that stuff.
the laws. So the real basic stuff like, well, let's see. Let's start with something that's not uber basic here.
Oh, yeah. The 2 go right there. Oh.
So I don't know if you guys remember this. What would log base 8 of 1 be? In fact, log base anything of 1. 0. Because 8 to the 0 is 1. Whatever is 0 to the 0 is 1. Anything that's allowed to be the base of a log anyway. And what's log base 8 of 1/8?
1?
Yeah, negative 1. Because you got to flip it, right? 8 to the negative 1 would become 1/8. And then log base 8, well, screw it. Let me just focus on this. So at 1, it's 0. If it's less than 1, it'll be less than 0. If it's greater than 1, but not quite 8 yet, right? Because log base 8 of 8 is 1. Again, you don't have to memorize this, but it's good to just kind of realize this, right? And it kind of helps you figure out the answer. So this question is going to have to be a root, not a negative. I didn't flip it to get to 2. I took a root of 8 to get to 2. And of course, which root did I take?
3.
Yeah, so it's going to be 1/3 power. So your answer to a log is always a power. Kick ass. Damien's like, I know what you want. You want power. Okay. So then that, of course, led to the properties of logarithms, right? So if I have log, become a log. Base, who cares? A times B. How could I rewrite that? What do you do with the powers when you're multiplying log bases? Yeah, so it'll be log base B of, so the power on that plus the power on that. It makes sense. I'm multiplying things with like bases. They both have base B. So I'm going to add the power on the first guy and the power on the second guy. That's why that property makes total sense. So when I divide, I'm going to subtract, right? When I raise, bless you, damn. Yeah, what do I do when I raise it with something with a power to a power? I multiply the powers, right? So I'm going to multiply that power times this power. So really, you just think that, of course, it just goes down. And like I said, that's one of the most important properties of logarithms. Why is that such an important property of logs? I was waiting for somebody to say it, Kyle. I heard it. Because you said it was, man. Because if I have an equation like 7 to the x equals 11.42, take the log of both sides because of this property, right? So this property enables us to solve equations where the variable is stuck in the exponent. Right? Logarithms can take that down. That exceptionally sucks. This equation sucks because my x is down in the denominator, but it's not hard to take care of. This exceptionally sucks because now it's stuck in the exponent, and I had to use a new idea to do this. So if I take the ln of both sides,
X, ln.
yeah, then x can come down. I can divide by ln of 7.
Okay.
Cool. So this would be the exact answer. Plug it in the calculator, get the approximate answer. Right? Students often think if there's decimals, it's exact. That's exactly wrong. Decimals normally mean you stopped somewhere, so it's going to have to be nothing but an approximation. This is exact. But I wouldn't tell somebody that this is the length of wood I need to finish building my house. That would probably give me a weird look. That's when I approximated with the decimal. Exactly. I was waiting for that too. Okay. So is that cool? Huh?
It's a natural law.
Yeah, it's a natural law calculator. There's the whole. Have you ever heard that joke? Yeah, all right.
No.
That's enough of that. If you hear it once, it's one too many times. So then what about I got a problem in there that's like this. So of course logarithms are how related to exponential functions.
The inverse?
They're inverses of each other. So they want to cancel each other out if they can get at each other. So the problem with this one is they can't get at each other. Because what's in the way?
3.
The 3. So what do I have to do with that 3?
3.
Yeah, so I always have people that kind of cross through and say the answer is 3m. That makes absolutely zero sense. I've got to consolidate this expression, and then these will kill each other, so I get m cubed. Cool. Is that good, Meg?
Yeah.
So that's stuff like number 8. And then there was a question on number 11.
13.
I was so close. 13. Oh yeah, that looks disgusting. That's... So, before I start writing stuff, what's kind of missing in this equation to be able to convert it directly to x and y?
That's why it was confusing.
Oh, that would be confusing.
Do you need
Did you need a... You okay? Where am I at here? Yeah. So what piece of this, like, how do I just not give this away? If I see a sine theta, why is that not quite good enough to go to x, y? You need an r. So right there, I see a sine, it's missing an r. I see a cosine squared, so each cosine is going to need an r, and it's only got one r so far. The whole damn thing needs an r. So I just multiply the whole damn thing by r. It's the first thing to notice. If I see r sine theta, it's y. So if I see sine theta, I'm like, it needs an r there. Shit. So I give it the whole damn thing an r. I end up with r squared for r sine theta plus 3r squared cosine squared theta equals 0. Right? So now r squared is x squared plus y squared. For r sine theta,
X, Y squared?
y.
Yeah.
And then r cosine theta is x, and so it's squared. I like it. Cool. And now you just gotta... What do you have to do to get this to look like a right conic section? There's one little extra piece out there somewhere you want to consolidate first.
We'll combine next round.
Yeah, get your like terms together. So you don't think it's a circle, right? Now you know it's a what?
Parabola.
Parabola.
I like the pronunciation, but no. Why is it not a
It's a hyperbola.
parabola?
It's
Because both the x and y are squared. Yeah, good. So it's going to be an
Hyperbola?
ellipse, yes.
Ellipse? Ellipse?
All right. So what's? How do I get it to look right?
Complete the set.
Complete the square. Kick ass.
Yeah. I don't know how to do that one.
All right. So who needs completing? Which variable?
Why?
Y. It's got y pieces all over the damn place. So I've got to consolidate that. So how do I figure out what has to go here to make this a trinomial that'll factor correctly?
you take half.
Yeah, half of 4 is 2, squared is...
4.
So you have to add 4 there, so I better...
Half.
Yeah. Since I'm doing it to both sides, I do the same thing. If it's all on one side, I have to undo whatever I do. The whole bag of sand, golden idol thing, right? Of course, that's going to factor like
2.
y plus 2 squared,
And then divide by 4.
divide by 4. So now, whoever you want to call A, whoever you want to call B, I don't care. It doesn't really matter. All right, so this will be, on the x-axis, I'm going to go out 1. On the y-axis, I'm going to go up and down
4. 2.
2. But away from what? What's the center?
0. Negative 2.
0, negative 2, kick ass. So you put the center down first, put a little open circle there because it's not a point on the graph, and then just count off from it. Same thing for a hyperbola. You would just put the center down first and then count off from it and then make your little box and go from there. Right? Same thing. Yeah.
Why is the center 0
Because that's how much has been shifted. Right? For an ellipse like this, the center is going to be at 0, 0.
Oh, okay, I get it.
Yeah, and of course for an ellipse there's no real center, but it's the center of the shape, whatever shape I'm working with, right? So of course it was like this, blah, blah, blah. It's been shifted over by so much, shifted up or down by so much. In this case it's been shifted down to kick ass. So now the center is at 0, -2. Put 0, -2, and then count off on the x-axis 2, on the y-axis 2, in the x direction 1. There's your ellipse. You can get your focus. The focus formula is going to have what operation in it?
C squared minus.
A squared minus b squared. Or big dude minus small dude, right? Just remember that. No imaginary foci. So C will be the square root of...
4 minus 1.
Yeah, you just said minus. Did I put square root of 5 on the stupid? Did I? Oh, good. All right. My brain suddenly felt like I had done that before. And, be careful with, this is a squared, so don't make it 16 plus 1, right? Don't square it again. You with me? Don't make that mistake. It's not a huge mistake. I'm not going to worry too much about the focus. Okay, cool. Is that cool, Elise?
Yeah.
All right. So I do kind of like to do that. I do kind of like to have you convert something that's in polar and then do something more with it once you've converted it. Yeah.
Pretty fun.
So for an ellipse, it's c squared is a squared minus b squared. So just, you got to put something there. It's the big guy minus the small guy. Right. For an hyperbola, it's nice.
A squared plus b squared.
And I know the hyperbola's got a plus because the hyperbola equation is the one that got the minus. Ellipse lets this guy have the minus and he keeps the plus. That's the way to remember it. Okay, good. And no, you cannot use that handout on the file.
What handout?
The conic section handout.
I get a tattoo of it.
The person in front of you. Tattoo on there. Get somebody with a big neck.
So on the test, metric for C is grad 3. Do you want us, when we state our focuses, put it in decimal form?
Now be careful. Let's go one step further on this. This is not the focus. This is actually how far the focus away from what?
The center.
Yeah, so again, I look at it just like I would A and B is how far from the center I go. C is how far from the center I go to get to the foci. So I would go up 1.7, whatever the hell that is, down 1.7.
But
So I think I put on the answer key the actual points.
are you wanting the actual coordinates on the
No, it's okay.
Yeah, good.
Yeah.
Can you over, the Descartes rule and all that for finding some,
Oh, yeah.
the shortcuts and all that?
Yeah, because I might ask you... Well, let's see. I don't know if I'll ask you too much about it.
Descartes, but well, no, just like because I know there's a bunch of shortcuts to figure out what terms you can.
Yeah, you've got... Descartes can sometimes be good and sometimes not. Right.
The changing signs and all that.
Oh.
That's
Plus
the,
or
yeah,
minus.
that's the one. That's the one we're talking about. So if I had... actually, the fourth. If I had that, how many positive rational roots could there be?
3, 2, or 1.
Yeah, there's 1, 2 changes in sign,
Oh,
right?
2 or 1.
So 2, or, and of course, why does it go down by 2? Because if it's not real, in fact, you can say this is real. I think nowadays they're teaching it a little bit differently than I was taught. The book here says it's real. If they're not rational, they would be irrational, and there has to be 2 of them because it would come from a quadratic equation, plus or minus, right? The way the book looks at it is, if it's not real, it would be complex. And if it's complex, it would come from the quadratic equation, which is plus or minus, right? So it's the same idea, either way you look at it. So there could be 2 or 0. It's got to go down by 2. Real roots, real positive roots. What about negative roots? How do you look at it? How do you do it?
Will you make all the odds?
Yeah, if this is P of X, you want to look at P of negative X. Remember that? Throw a negative X in. So all the odd powers are going to change sign, because all the even powers would just kill that negative. So now it's x4 plus 2x cubed plus 3x squared minus 7x plus 1. So in this one there's also 2 or 0. So in this case he really doesn't give us much help. Right? It helps out the best if it turns out that one of these comes up with exactly 0, because then you can cut your list in half. Remember that?
Yeah.
Plus or minus, you can take one of those off. Cool. And you're all like, no, I don't remember that. Well, you got some time, just in case I do ask you that. But I mean,
Get this factor than 9, right? To figure out what
good. So that's the kind of question I definitely will ask you, even though I kind of implied it here on number 5.
Yeah.
Because you have to make a list of things to try if you want to do synthetic division. You're not going to just start picking 2, 7, 28, I don't know, shit. So how do you, let me put a little more complicated example up here than number 5. Number 5 is pretty easy.
Yeah.
But if I had 6x squared,
Oh, then you do the track.
let's do 7 power minus 4x, 4, who cares? Minus, what? 21. Someday I'll get it up.
Factors of that over factors.
Yeah, so it'll be the plus or minus factors of 21
Over plus or minus of 6.
over the factors of 6. So it'll be 1, 3, 7, so on. 6 would be 2, 3, 6. So now every possible, so it'll be plus or minus 1, 1/2, 1/3, 1/6.
Yeah.
3, 3/2, 3/3 you got already, 3/6 you got already, and so forth, right? Don't stop here. This is not good enough. That's like telling me, yeah, Jeff, just do the work a little bit. You'll see. No. I'm asking you to do the work. You show me the actual list. Yeah.
Then you use, like, if you can, Descartes to kill some of those numbers.
Exactly. So if Descartes, if this is all of this was plus,
You'd kill them.
there would be no what?
Positive.
No positive roots, because there'd be no sign changes in P of X. So then I could just make the list out.
Negative, yeah.
And it's still a pretty damn long list, but I just, it's because I'm not knowing. But I just cut it in half. That's pretty good. Right? So realize that the final is going to be a little bit more time than normal. We normally have like an hour and a half for, is that true?
Yeah.
Yeah. For tests. Now we're going to have 2 hours.
Is it going to be the same?
But I can't go crazy with it, right?
How many questions are you going to make the test?
Normally my finals are somewhere in the 20s. But, counting all the ABCs. And,
okay.
Yeah, they're not going to be 20
Separate questions with
prompts
ABCs.
like this. Now,
Maybe 4 hours.
graph this polynomial by doing, no, screw that. Yeah.
What is it when we used to cancel, let's say, 3 and all of the other numbers?
Oh, like an upper lower bound.
Yeah.
Yeah. So, if you divide by a positive number and it comes out all positive, that would be an upper bound. If you divide by a negative number, it comes out
All negative.
alternating. Remember that? It comes out alternating, that would be a
Lower.
lower bound. So if I synthetically divided by 3 and it came out all positive, then I could eliminate 7 and 21 and anything other, 7/2 and 7, everything that's bigger than 3, I could eliminate, because that would be an upper bound. Right? Cool. I like it.
You said the negative one was...
Now, do you think I'm going to make a problem that actually has this humongous list?
No.
Because you don't have a lot of time. I don't want you getting bogged down in that one problem. But you do have to prove to me that you know how to make a list, and you do have to prove to me that you know synthetic division. Those kind of things. Yeah. Okay.
Yeah.
Do you guys remember multiplicities of roots and what that means when you're graphing?
Oh,
Does it turn? Does it go through?
Oh, yeah.
Remember that stuff? Yes, that's all in number 6, right? Behavior at the roots. When I say, yeah, there it is. Behavior at the roots. That's the multiplicities telling you, does it turn at the root or does it go through at the root?
It's like
Do you go over those rules real
the
fast?
Yeah, so if
squared
I had,
is through, right? No, through.
hey, Dad, what are my x-intercepts?
Yeah.
No.
0,
1.
0.
and 1.
And what's the multiplicity at
3.
each?
At 0.
0, 0
goes-
returns.
What's the multiplicity? How often does it show up? Twice.
3.
3 times. So what's it going to do at this one?
Turn.
Turn like a parabola, because it's what a squared thing does. And this is going to go
Through.
So if it's an even multiplicity, it's going to turn like a parabola would. Odd multiplicity is going to go through like a cubic cube would, right? That all happened in this
It's
semester.
just so boring.
6-unit course, pretty dense, all right? Pretty dense in stuff. Blah blah blah. How would you figure out the end behavior for this guy?
X
Times.
Can you guys just tell me the highest rate if that would happen if you did multiply that out?
X to the
Do not multiply that out. Right. So yeah, this is going to be like x to the 5th. So yeah, exactly. It's going to be like that. I like that. So if it was negative x to the 5th, it would have been like yeah, that. I like just that. That's awesome. If it was x to the negative x to the 4th, it kicks ass. Before you guys playing with me, so don't fill in the middle. Just do the ends. You don't know what the hell's still in the middle. Blah blah blah. So yeah, good. I like it. Okay.
I like that. I don't have anything else for you.
Oh,
Yes.
are we gonna be remembering all
I
the
hope so.
identities? Most likely, the identities.
So all the ones I said you had to memorize, all the ones that were above
From
that
that
black
test.
line, you have to know those trig
Okay.
identities. Yeah.
Okay.
Cool.
No trick.
Yeah, it's kind of funny. I don't have a ton of trig down here, do I?
You down.
I don't. But you know you're going to have at least this, if not more. Right? I have one identity proof down here.
Yeah.
Right? I probably can't give you too many of those because they're really easy to get kind of stuck in. That's right. On the East Coast, I used to have 3 hours for a final. That was awesome. It was epic. People would just melt or something. Oh, I can't. Scoop them out of the chair. Go reconstitute yourself.
For number 9 would just be the inverse, whatever. Be the triangle, right?
Oh, yeah, so you set up the picture.
Yeah.
The one with the kite, right?
Yeah.
Now, what do you mean by inverse?
I don't know. You would.
See, that number 9 is a classic.
Yeah.
Immediately, very soon after you first learn trig, you can do that problem 9. Right? Because that's the very first use of trig functions is to help you solve things about right triangles. If you want to solve stuff about non-right triangles, you have to use what?
Law of sines.
Law of sines, law of cosines. Cool. So we build it off of the right triangles, and then we kind of extrapolate out, make the formulas look worse, right?
Yeah.
Cosines was like Pythagorean theorem on steroids or something. It's got that extra piece at the end, right? And sines was just an idea of ratios of sides. I've scheduled 2 days of review. Maybe that's too much. I don't know. I'll tell you what. On Monday, so you have this. You have the practice final. You have the answer key. On Monday, I might make a little something for people to work on in class not too exceptionally long, so then we have some time to go over it, just to put you in a situation. Because then our final is going to be, when is our final?
Tuesday.
Yeah, the first day, right? So that's kind of nice. Yeah.
But we can still ask questions about this on.
Of course, yeah, please. So if you haven't had time to try this whole thing out, obviously do that before Monday, yeah. You can still turn in test corrections on Tuesday. Yeah.
I remember. What time's your final on Tuesday? There you
I
go.
put it on the grade sheet summary thing.
No, that was mine.
Be careful. Yeah, we start 5 minutes early, so be a little careful. It's always a little psychological thing if you walk in 5 minutes late. It's not too late, but your brain's like, oh shit. Or it should be anyway. Some people that didn't seem to face them. Walking an hour late, no problem, man.
What time does it end?
It's 2 hours after. Yeah. Thankfully, they finally built in 10 minutes of cushion. I used to have to run from one final to the next, like you guys probably had to. Remember that? It would stop at 11:30, and the next one would start at 11:30, and the next teacher's like, "Let us in," and I'm like, "They still have time." Not quite as exciting as Game of Thrones, but still. Game time. We have time. It's our time. Get out of here.
Fake, stupid, fake, simple questions. Combining